Now in the first part of the exercise, we should sketch the optimal hyperplane and provide the equation of the hyperplane. So here's my sketch, and now let's provide the equation. So I hope that you could have seen here from just looking at the points that the hyperplane must lie between those points here, and most likely those will be our support vectors. I think you can guess that. And also you have to get the assumption that the distance between all the points will be equal. So maybe I should have given that as a hint, but otherwise you would have needed to actually apply the Lagrangian to get to this form of the hyperplane to derive the weights. So we will actually not derive the weights that way because this will take much too long and is too complicated. So let's just go with this, and you can also easily find out that the form must be then x2, which is basically here the y-axis, is equal to, and then starting from the intercept 1.5, and then the slope here must be equal to 1, so x1. And now let's bring this in our known form. So x1 minus x2 plus 1.5 is equal to 0. And that means that our weights are 1 and minus 1. And our constant here is 1.5. Now in the second part we should say when a point is classified as lying above the line and when it's classified as lying below the line. So when is our prediction y is equal to 1 or y hat is equal to 1, and when is it y hat is equal to minus 1. So let's say this is exercise part 1, 2, then it's if this condition here is fulfilled and it's greater than 0, then y hat is equal to 1, and if this condition is smaller than 0, then y hat is equal to minus 1. Now in the third exercise, I think we should tell what the support vectors are. Yes. So we calculate the distance or the margin here using our L2 norm. So this is the definition from the lecture. And then the distance is basically all of this. So let's divide this by 2. And then we have just this distance here. then this will look somewhat like this. So this should be the corridor that the margin spans, and then you know that those 4 must be the support vectors. And in the last part of the exercise, we wanted to know where we could place a point so that we couldn't use the maximum margin classifier. And this could be, for example, here a red point. Then we couldn't split the 2 sets or the 2 classes by a simple line anymore. And now how do we overcome this? Using the support vector classifier and then allowing points to lie on the wrong side of the hyperplane, or also to use a different kernel. So this is basically part 4, and then also this here.